Hello, I want to show you how to do this activity on IXL. Write variable expressions. Notice a lot of students have trouble with it, so let's walk through it closely together. First of all, I want to remind you what we mean by variable expressions. Remember, a variable is just a letter that represents an unknown value. So this letter could be A, D, C, B, T, W. It doesn't actually matter what the letter is. All that matters is that this letter is showing you that there is a value that you don't know in the expression. So for example, 6 plus W. That W is unknown. It could stand for 75, in which case 6 plus W would mean 81, or W could stand for 3, in which case 6 plus W would be 9. So we don't know what that W is, so we just leave it as W. It's a variable. It's a letter that represents an unknown value. And then we talk about operations. Operations are when we use the plus, minus, multiply, divide. It's these right here: addition, subtraction, multiplication, division. And it's what we do to relate numbers and variables to one another in an expression. And an expression is just like this one above, 6 plus W. It's a relationship between numbers and variables expressed with operations. So another example of an expression might be 7t minus 8. That's an expression. 7 times t minus 8 is an expression, and it would turn into an equation if we put an equal sign next to it and then had some kind of answer. So 7t minus 8 equals negative 8 would be an example of an equation. But right now all we have is an expression, just this unsolved expression involving a variable and its relationship to numbers. So let's review really quick what these operations are, and especially the words that we use to explain them, because that's going to help you a lot in this exercise. So, for example, addition can be expressed with the words increased by, plus, sum or total of, added to, or more than. So let's go to the IXL. On IXL you can see write an expression for 322 plus z. So basically what this is asking for is literally just 322 plus z. So I'm just going to type that in just like that. I think I don't want the spaces. This is the expression that we're just writing out in symbols that they've explained to us in words. Awesome. We're going to come back to that in just a minute. Other words for addition, we just use plus. There's also increased by, so s increased by 7 would be s plus 7 using the plus sign. You could also use added to or more than. And addition is commutative. What that means is that the order doesn't matter. So for example, in the one that we just did, z, you could do 322 and then the plus z, or you could actually just do the z plus 322, and you would get the same answer. Let's pretend that z stands for 5. 322 plus 5 is 327. 5 plus 322 is still 327. So addition is commutative. It doesn't actually matter what order you do it in. Multiplication is also commutative, and we'll talk about multiplication more in depth later. But for now, just remember 3 times 5 is the same as 5 times 3. Both of those will equal 15. So it doesn't actually matter what order you put it in when you start using variables. You can do 3 times d, or you could do d times 3. Either way, you end up with the same expression. Subtraction and division are not commutative. That means that the order matters. So the order you write it in is going to determine whether or not your expression is correct. For example, 5 minus t is going to be different than t minus 5. So if, let's say t equals 3, 5 minus 3 is equal to 2, but 3 minus 5 is equal to negative 2. So it actually really matters in subtraction what order you put the letter and number in. The same is true for division. 6 divided by 3 is a different problem than 3 divided by 6. 6 divided by 3 equals 2. But 3 divided by 6 equals 1/2. So be careful that you don't change the order for division problems. Okay, so I want to talk a little bit more about subtraction. On some subtraction problems, you're going to notice that it says subtracted from, less than, or fewer than. Whenever it says subtracted from, less than, or fewer than, you have a hint as to what the order is going to be. Let me show you an example. If I just say 6 minus q, then what I have is 6, the minus sign, and q. That's 6 minus q. But if I have 6 fewer than q, that word than is a hint that you need to switch the order of q and 6. I'm starting with q and I'm subtracting 6 from it. So these are the phrases where you know you need to switch the order. Subtracted from, less than, and fewer than. So if I have, for example, if I have 70 subtracted from w, it's subtracted from w, which means that w is your starting number, and then 70 is being taken away from it. So it's going to be w minus 70. So that phrase subtracted from is a hint that you're actually going to switch the order from what it says in the written expression to how you write it in your expression using numbers, variables, and operations. But if it just says subtract, w and 70, then you can just do w minus 70. The order is the same in the phrase as it is in the expression. Okay, so let's do this problem. It says, write an expression for 343 fewer than h. So it has that phrase fewer than, so I'm going to start with the h, put in minus, and then 343. If it said just 343 minus h, then I would keep the order the same, and I would do the 343 first. But that phrase fewer than, just like the phrase less than and the phrase subtracted from, is a hint that we need to change the order, because we're starting with the variable, we're starting with that value of h, and we're subtracting that 343 from it. Okay, awesome. So let's talk about multiplication really quick. Multiplication can be shown in different ways. You might be used to thinking about multiplication as this kind of X sign. So 3 times D, I might write like that. Here's the problem, is that when we get into algebra, that X symbol becomes really inconvenient because that x could stand for times, like multiplication, or it could be a variable. So it kind of becomes a problem. So when we use multiplication in writing expressions, there are different ways we can write multiplication. I'm going to show you 3 of the most common ways. One is to use a little dot instead of the x symbol. So if I wanted to say 3 times d, I would do 3, this little dot, and then d. Now remember, multiplication is commutative, so I could also do d times 3, and either one is correct. Another option is you can use parentheses. A parentheses between 2 numbers or between a number and a variable always means multiplication. So I could do 3 times d like that. Or of course I could switch it. And finally, if I have a number and a variable together that I'm multiplying, I can actually just put them together with no sign. But when you do that, just make sure you put the number first. Not because it matters in terms of, remember, multiplication is commutative, but people always just write the number first when they do this. So let's say I have 3d. That just stands for 3 times d. It's the same as if I did 3 times d, and it's the same as if I did 3 parentheses d. All of these are ways of writing 3 multiplied by d. They're all written expressions for multiplication. Division can be expressed often. What we've seen it expressed as is this kind of division symbol. It's like a dot, a line, and a dot. So 6 divided by 2 would be just like that. When you write it on IXL, it's going to have you put in a slash instead of this division sign. So if I wanted to write 6 divided by 2, for example, I would put 6, a slash, and then 2. The reason why it's having you do that is because 6 divided by 2 is actually just a fraction. Remember, fractions are division problems. So this fraction 6 over 2 is the same as 6 divided by 2. And so in IXL, you can just put that slash to represent kind of it being a fraction. And just be careful of what order you're dividing things by. So if you have 7 divided by a, you have 7 over a. You can do 7 slash a. Or they could say, what's the quotient of 7 and a? And that would be also 7 divided by a. And that's going to be a different answer than a divided by 7. So you might notice some words that you don't recognize. Quotient might be one of them. All of these words, sum, difference, product, and quotient, are words for the end result of that operation. So a sum is the end result of addition. Difference is the end result of subtraction. Product is the end result of multiplication. And quotient is the end result of division. So I can have the sum of 2 numbers, the difference of 2 numbers, the product of 2 numbers, or the quotient of 2 numbers. But basically, for your sake, all you need to know for this exercise is kind of what column it falls into, whether it's an addition problem, subtraction, multiplication, or division, and that will set you up to be able to put in the correct sign. So that's enough explaining. Let's go back to IXL and try some more problems. It says write an expression for the sum of t and 50. So I'm going to do t plus 150. And remember, I could do 150 plus t because addition is commutative. Write an expression for a and 10 more. So this is going to be an addition problem. A plus 10 because I have a and then I have 10 more than a. So it's written a little bit differently, but it's the same idea as that phrase more than. That word more is referring to addition. Awesome. Let's do 81 minus u. 81 minus u. That's pretty straightforward. 17 more than s. So write an expression for the product of 206 and z, and then it says type a slash if you want to use a division sign. It starts putting in this instruction just in case you want to use division, but just because it has this instruction doesn't mean you actually need to use division. So that word product, let's refer to our chart. Product is under the column for multiplication, so this is a multiplication problem. So write an expression for the product of 206 and z. So what I'm going to do is I'm going to put the number 206 and then I'm just going to put z right next to it. And that's implied multiplication, and that is definitely going to work. Write an expression for 78 less than j. So that than is a hint that we have one of those phrases that shows us that the subtraction order is going to be different, that the order needs to be switched. So we're starting with the j minus 78. All right, s divided by 179, so now we have s slash for division and 179. All right, and I think now it's your turn to try. And if you need to, I'm going to show you this video one more time, or this chart one more time. So if you need to, pause the video now to copy down any of these words that you think will be helpful to you.